Are you
Good.
seeing my screen with the clouds?
Yes.
Okay, great. All right, well, let's see. So I'm a professor at UWM in my 33rd year. And I've been giving presentations in one form or another about clouds for a very long time. And so this presentation, this set of slides that I'm showing you keeps growing and changing over the years. And many of the slides are from people who have seen some iteration of this presentation and have sent them to me. So I would encourage any of you guys to do that too if you see any cool clouds, because I'm always trying to add to this and make it better. All right, so let's go. So here's a definition of a cloud. A cloud is not water vapor because water vapor is invisible. And I don't like to use the word steam because steam is a little bit ambiguous of a term. Engineers will say that steam is liquid water drops, like the stuff that you can see coming out of your tea kettle. But if you can see it, it's not gas, it's liquid. So I prefer to use water vapor, and the other two forms of water are solid and liquid. So a cloud consists of many, many millions of visible pieces of water, either water droplets or ice crystals or both, that are suspended in the air. Now, for sure, there's plenty of water vapor in there too, but that you can't see that part. Okay, so oops, let's see. How do I get this to go? There we go. All right, so first of all, some clouds are made of liquid, some clouds are made of ice, some are both. It's very easy to tell the difference. So the one on the right here is an example of a water cloud. So with water clouds, that I mean liquid water clouds. With water clouds, it's very easy to see where the cloud stops and the sky starts. The borders are distinct, whereas ice clouds, the ones on the left, have very diffuse borders. If you have 10 artists painting pictures of the cloud on the left, you're going to get 10 very different looking pictures for the ice clouds, but much more agreement for the water clouds. And the ability to identify ice and water clouds is helpful because it tells you interesting things about the weather and in some cases about the forecasting. For example, ice clouds typically occur at higher altitudes where temperatures are colder. That's interesting to know. Okay, so let's see, here's an example of some ice clouds. This is called cirrus. The streaky things are called fall streaks. So that is snow that is sublimating before it reaches the ground. Sublimation is like evaporation. Evaporation is when water changes phase from liquid to gas, but sublimation is where it changes phase from solid to gas. And that's what's happening. It's snowing here, but the snow isn't reaching the ground. This is actually fairly common here in Wisconsin in the winter. Here's an example of water clouds. Not particularly exciting looking, but if you compare the difference, you can see what I mean about the edges being very distinct here and not so in the other one. Okay, here's an example of a sky with both types of clouds, water clouds and ice clouds. So here you can infer something about the altitudes of the clouds. In the atmosphere, in the lowest 10 kilometers or so, that would be the lowest 6 miles of the atmosphere, the temperature typically decreases as you go up. So that means the higher you go up, the temperatures are colder. So the ice clouds that you see in the center and the top are higher, and the water clouds that you see everywhere else are lower. This is an example of a slide that was sent to me by a student. I teach a course in meteorology in Mexico every summer. So some of these cloud photos are from those guys. Okay, so I'm going to show you how we can classify or identify clouds. There's three methods of identifying the clouds, and they're based on different things as shown here. So I'm going to go through these. So as far as identifying clouds by the height of the base. So now clouds, they often have a vertical extent. They're not just flat. So if you say, I'm going to identify the cloud based on altitude, it's legit to ask the altitude of what part, the bottom, the middle, the top. So the answer to that question is the bottom. So if the base of the clouds are low, less than 2 kilometers, so 2 kilometers is 1.6 miles, 1.2 miles, sorry. Low clouds, middle clouds, and high clouds have these ranges of their bases. Now, this is, excuse me, this is an important component to identifying clouds because sometimes the cloud itself is almost exactly the same type of cloud with the same physical dimensions, but it occurs lower in the atmosphere or higher still. These clouds that you see here are all the same type of cloud. It's called cumulus type. Each individual cloud element is more or less the same size. So you can see the individual elements clearly in the lowest image, the low clouds. For the middle clouds, the individual elements are the same size roughly. Sorry, my voice is going. Same size roughly, but they appear smaller because they're farther away. And same comment, even more so for the high clouds. Those individual elements that look kind of like grains of salt are the same size as in all these photos. It just looks smaller. Okay, so here's an example of some high clouds. So the base of these clouds are somewhere in this range. Meteorologists, as part of their training, learn how to estimate the base of clouds. It's hard to do because it's not, I'm sorry, estimate the height of the base of the clouds. It's not an obvious skill. It's not an easy thing to do. So these are in this range. They're pretty high. Here's the middle ones. The middle clouds, in my opinion, tend to be the most beautiful. These are called altocumulus. I'll get into the specific names in a bit. They are both of these kinds. This is the last one. The high cloud, cumulus type, the middle cloud. These are both fairly common around here, but problem is they move pretty fast. So if you want to see them, you have to look at the sky often, like maybe a few hundred times a day, look up. That's something that a lot of people don't do. You guys, I heard some talk about identifying birds. So I imagine you guys occasionally look up, and that's a good thing. So here's another picture of some low clouds. Okay. So let's go to the next way of classifying clouds. So that's based on appearance. Now, all of these three types of appearance, way clouds look, all these three, they occur at the low altitudes, the middle, and the high altitudes. So we've already got 9 cloud types now that we're talking about. 3 times 3. So I'm going to go through them for you. So cumulus type clouds. Cumulus are the puffy cotton ball type clouds. Cumulus comes from, I think, a Greek word accumulate, like a puffy cotton ball-ish color. So this is a pretty photograph because it occurs at either sunrise or sunset. I forget where it catches the colors. Cumulus type cloud. Now, stratus type cloud, strata, like stratigraphy. It means layered or flat. So a stratus type cloud is typically covers the whole sky. With the cumulus type cloud that I showed you before, there are areas of cloud and areas of not cloud, clear sky. Not so with stratus. Stratus covers the whole sky, and depending on the altitude, it could be gray, ranges in colors anywhere from gray to milky white. And nimbus type simply means the cloud is precipitating. So a stratus type cloud could also be a nimbus cloud. It's called nimbostratus. A cumulus type cloud, it might be called cumulus, but as soon as it starts precipitating rain or snow, it gets a different name like cumulonimbus. Okay. So now, I've been telling you sort of about the strategy of how we classify clouds. Now I'm going to show you some actual examples of specific cloud types. So we're going to go through low clouds, the middle clouds, high clouds, and then a few other categories. So low clouds like the cumulus and stratus, which I'll show you in a second, those are just called cumulus and stratus. But if those cloud types are located in the middle altitude range, then they get a prefix alto, like a singer or something, higher range. So that would be an alto cumulus and an alto stratus. And similarly for the high clouds with a different prefix. So let's get to it. So low clouds, there's four main types. There's stratus, and then there's stratus that are raining or snowing. Those are called nimbostratus. Same cloud, but it gets a different name as soon as precipitation starts. And then there's cumulus. We talked about those a little bit. And then there's a cloud that's sort of a combination between the two types, has features of stratus and also features of cumulus. So those are cleverly called stratocumulus. So I'm going to go through these types now. Here's an example of stratus. Boring, gray cloud, covers the whole sky. You can't see the sun through it. Unfortunately, very common because nobody likes these clouds. Now here's nimbostratus. So you have a stratus type cloud and it's raining. This photo isn't the best, but you can see the puddles. But you can clearly see that the sky is uniformly covered by cloud. So that makes it a stratus type. And since it's raining, it's a nimbostratus. These little raggedy elements that hang below the cloud, that's called scud. It's just little fragments of the cloud that have broken off and are probably moving across with the wind. All right, so here's cumulus. Now you've seen these before. Here's another one. Now notice that with cumulus cloud, there's individual cloud elements with clear sky in between. So the reason for that is the way it forms. So cumulus clouds are formed by convection. That means rising bubbles of warm air. So what happens is the sun warms the ground warms the air right next to it. We're talking about a very thin layer of air, maybe millimeters thick, hugging the ground. And warm air rises. So that air rises. And when air rises, it expands and cools. And eventually it reaches a temperature where the water vapor, the invisible water gas in that air, condenses into liquid. So that's called the dew point temperature. And when it reaches that temperature, which occurs at a certain altitude, then a cloud forms. So these clouds, cumulus clouds, which are very common around here, especially in the warm season, are a visible marker of rising bubbles of warm air, which is interesting because air is invisible. Normally, you can't see it when it rises. Now, what comes up must go down. So all the air can't rise. If that were to happen, we'd lose our atmosphere. That doesn't happen. So the areas of not cloud that surround the individual clouds are areas where air is sinking. And when air sinks, the opposite happens. Air sinks and it gets warmer. So the temperature gets farther away from the dew point temperature, and clouds don't form when air sinks. Clouds form when air rises. So this is it's a very common looking picture, but it's interesting because it shows all this cool invisible stuff that's going on. Air is rising underneath the clouds and sinking between the clouds. And also, since you guys are apparently interested in birds, tell you that. So the cumulus clouds are visible markers of thermals, rising areas of warm air. Another visible marker of thermals is soaring birds like hawks and other soaring birds. I don't know much about birds, but you see these birds sometimes, they'll be soaring, up high. They'll be flying with their wings open, not flapping. So obviously, they're able to gain or maintain altitude without flapping their wings. That's because they have found one of these thermals, the same ones that cause the clouds. Okay, so here's an example of stratocumulus. So you can see that the clouds cover much of the sky, yet they're individual element clouds, which are sort of crammed together to create a greater coverage. But so they incorporate elements of both cumulus clouds and stratus clouds called stratocumulus. Stratocumulus clouds like these are the most common cloud type on Earth because they're very common over the ocean, and about 70% of the Earth's surface is covered by ocean. So this is by far the most common cloud type. Meteorologists make nerdy jokes about stratocumulus. I've known some people who went to school at Penn State and they call it stratocu because there's lots of stratocumulus there in the winter. There are here too. Okay, let's go to the middle clouds. So middle altitude clouds. We have cumulus type clouds and stratus type up there, and they get the prefix alto. So here's an example of altocumulus clouds. I took this photo outside my house 2 days ago. I live in Glendale. So these clouds are obviously in individual element cloud with clear sky in between, so cumulus type. But how do you know whether it's altocumulus, as I claim, or cumulus, the lower type cumulus clouds? Well, I'm gonna show you a trick here. I'm gonna stop sharing my screen for a second. Well, no, I don't need to. You guys can all see me in the corner, right? I think you can.
Yes,
Yeah, we can see you. Yep.
Okay, so there's a trick for identifying which type of cumulus cloud you're looking at. So if you see a cumulus cloud, a cumulus type cloud, what you do is you raise a fist at arm's length from your head and block a cloud with your fist. If the approximate size of an individual cloud is about the width of your fist when it's extended at arm's length from your head, then it is a cumulus cloud. In other words, one of those lower ones, the low cloud cumulus type. If, on the other hand, the individual element of a cloud is approximately the size of your thumb held at arm's length, then it is an altocumulus cloud like you see here. And if, on the third possibility, the individual cloud elements look like sort of grains of salt in size, then those are the highest ones, which are called cirrocumulus. Okay, now you can identify cumulus clouds. Here is a picture that was sent to me of some altocumulus clouds. One of my Mexican students. Altocumulus clouds at sunrise or sunset are some of the most beautiful clouds you're going to see in the sky. But you got to look because they whip across the sky kind of fast. All right, here's some special type of altocumulus clouds. Sometimes, even around here, but it's rare, sometimes these clouds form in linear patterns that are called cloud streets. So cloud streets are really interesting because they show you how the air is moving. Now, meteorologists are obviously interested in how the air is moving all the time, but just with your eyeballs, it's hard to tell how the air is moving because air is invisible. But when you see cloud streets, so here's one, I have another picture here. They give you some very detailed information. So when you see clouds like this, what's happening is the air is moving in waves, and it is moving perpendicular to the cloud streaks. So for example, here, the air is moving either from left to right or right to left. I don't remember which. And what's happening is as the air moves, let's say it's right to left, it's moving horizontally, but it's also moving in waves. And when the air is at the top of a wave, it's a little bit colder than it is at the bottom of the wave. So the air forms at the top of the wave, and the cloud forms at the top of the wave, and then it evaporates at the bottom of the wave. So seeing these cloud streets tells you that the air is moving in waves. It tells you the direction that the air is moving. It's either right to left or left to right here. It indicates that you have where the crests and the peaks of the waves are, which is pretty cool, I think. A couple more pictures of cloud streets. I took this picture from an airplane. This is from a satellite north of Alaska, or I should say west of Alaska, sorry. Okay. So now we'll move to stratus type clouds. So that we're at the middle, we're talking about the middle altitude clouds. So I showed you a bunch of cumulus, the altocumulus clouds. So this is an example of altostratus. So it's definitely a stratus type cloud because the sky isn't clear. There's definitely clouds there, but they're not individual element clouds. The clouds are, the sky is sort of universally this gray or milky color. So now the question is it a stratus cloud, meaning the low altitude one, or is it an altostratus cloud, the middle altitude one? Well, the trick here is that in altostratus clouds, the sun is dimly visible, like in this slide. You can see the sun and it doesn't hurt your eyes to look at it. Whereas for the low altitude stratus, you can't see the sun. Now there's going to be no shadows in either case, but here you can see the sun, so you can identify this as an altostratus. Okay, moving on to high clouds. So higher altitude clouds, again, we have the two types that I've been harping on, cumulus type and stratus type. But we also have two additional types which only occur at these high altitudes. One's called cirrus, and then the other one, the condensation trails, is a anthropogenic cloud, meaning a human-made cloud. So let's go to it. So these are cirrostratus clouds. So individual element, I said it wrong. These are cirrocumulus clouds. Individual element clouds, not stratus type, definitely cumulus type. But if you do the trick, you hold your fist at arm's length and try to block one of the cloud's elements or the thumb, you'll see that these appear smaller, much smaller than even your thumb. and that identifies them as cirrocumulus clouds. Cirrocumulus clouds are also beautiful clouds, especially at sunrise and sunset when they take the colors. But at higher altitudes, the winds are stronger. So these clouds tend to be short-lived. I see them around here all the time because I'm sort of a nerd when it comes to the sky, and I'm looking at the sky all the time. Beautiful clouds, and they're here a lot. You got to look for them. Okay, now here's an example of cirrostratus clouds. So if you ignore the optics, the rainbow looking things, they're not rainbows, but if you ignore that for a moment, you can see that the sky is not clear in these pictures. It's not just brilliant blue. There's something there like a milky white something, those are clouds covering the whole sky. So those are stratus type clouds, but the sun is shining brightly through them. The only way you can take a picture of these is if you block out the sun. Otherwise, the light from the sun swamps the photograph. So cirrostratus clouds, the sun shines brightly through them. So let me remind you about the three types of stratus clouds. The low ones, stratus clouds, the sky's gray, the sun doesn't shine through them, no shadows. Altostratus clouds, you can see the sun as sort of a dimly lit disk of light. Doesn't hurt your eyes to look at. Probably shouldn't look at it. It's probably bad for your eyes, but you can look at it for an instant and it doesn't hurt. Cirrostratus clouds like these, the sun is bright. You can't look at it. It'll blast your eyes out. You might even get shadows cast by the sun. Now, the other thing about cirrostratus cloud is that way up high at those altitudes, the clouds are always ice clouds. Well, I shouldn't say always, almost always ice clouds. So the clouds are made of ice crystals, and these ice crystals act as prisms, and they create beautiful optical phenomena. Now, some people will see stuff like this, and they'll refer to it with the word rainbow, and that's not correct because, first of all, it's not raining, but aside from that, rainbow is an optical phenomenon involving water droplets, liquid water. These are ice crystals, solid water, okay, not rainbows. You do have the separation of colors like prism, like you have in rainbows, but not rainbows. So these ice crystal optics, as they're called, are occur only with cirrostratus clouds. So the optics themselves are another way to identify cirrostratus clouds. So here's a trick for you. If you think there might be cirrostratus clouds in the sky, what you don't want to do is look up at the sky, because what's going to happen is the sun will be in your field of vision and it'll sort of blast out your eyes and you won't be able to see anything. So the trick is you want to look down, and while you're looking down, raise your hand up like this and block the sun. Try to position it so that when you look up, it will block the sun, and then you look up. And if you look and you block the sun, just as in these photographs, the sun is blocked, then not only can you see the cirrostratus clouds without your eyes being all blasted, but if there are optics there, which there often are, you can see them. And wearing polarized sunglasses helps too. One time when I was teaching an introductory meteorology class, doing a little unit on clouds and cloud identification, I asked my students one day, they came into the class, and I said, what type of clouds are outside right now? And the class, the auditorium that I was teaching in didn't have windows, so they couldn't cheat and look out the window. And, of course, nobody offered an answer. And so I said, okay, how many of you think that there are cumulus clouds? And some people raise their hand. How many think there are stratus clouds? Some other people raise their hand. Some people raise their hand for cirrus clouds, when actually the sky was perfectly blue and clear, no clouds at all. So it just sort of demonstrates that people don't look up. If you look up, you see cool stuff. Okay, so this is one of the two types of clouds I was telling you that occur only at the high altitudes. It is not a cumulus type because it's not like puffy individual element, really. It's more like filamentous, right? Filaments, sort of. It's not stratus because it doesn't cover the whole sky. It's something different. So this is called cirrus. And cirrus occurs only at the high altitudes. Cirro, C-I-R-R-O, is the prefix that is used for the cumulus and stratus type clouds that occur at these high altitudes. But clouds like this, which are neither stratus type nor cumulus type, are simply called cirrus. So these are ice crystal clouds, obviously, because the borders are distinct. I'm sorry, are indistinct. They're sort of diffuse. My dad lives in Tucson, and I go to visit him once or twice a year. And we try to get up to the Grand Canyon if we can. And at the Grand Canyon in the summer, the sky is a brilliant blue, and it's a great place for cloud enthusiasts. So I have a bunch of pictures that I've taken there of cirrus clouds. Here's an example of cirrus clouds and some cumulus type cloud towards the bottom there. Here's another one. You see cirrus clouds to the left and some cumulus type clouds that are called vertical development clouds. I'll get to those in a minute at the Grand Canyon. All right, here's an example of man-made cloud, anthropogenic clouds. It's called condensation trail. So these are clouds that are made from aircraft exhaust, and they're very common. And see, do I have another picture too? No. Okay. The mechanism by which these clouds form is interesting. So an aircraft is flying, zooming through the sky, and the big engines in the plane are emitting exhaust as it flies through. And the exhaust gases include water vapor. So what happens is there are two things that happen. One is that the water vapor that exits the exhaust pipe or whatever it is in the aircraft engine is very, very hot, and it cools quickly, and the water vapor condenses to water liquid, or perhaps it goes directly to ice. That's one reason that you can see these clouds. Another reason is it's a more physical reason. So as the aircraft is flying through the air, it is literally pushing air away as it flies through, creating like a tunnel that it can fly through. And when it does that, it is lowering the pressure as it moves the air out of the way so it can fly through. So as soon as it moves past a particular area, then that tunnel that it created by moving the molecules away, the air rushes right back in. And when the air rushes in, it expands to fill that hole. And when air expands, it cools and the water vapor condenses. So the clouds form by both of those methods. Okay, so check my time here. I'm doing okay, I think. So we talked about cumulus type clouds, stratus type clouds at the three different altitudes. Now, some clouds are so tall that they occupy all three altitudes at once. So those are called vertical development clouds. So vertical development clouds, they go through a sequence. They start out as cute little cumulus clouds, just like the ones that I showed you. And they grow taller. And eventually, what happens is the top of the cloud reaches a part of the atmosphere that's called the stratosphere, generally about 10 to 15 kilometers above the ground, say 6 to 10 miles above the ground. And the stratosphere forms a kind of sort of barrier to further vertical growth. Now, it's not an actual physical barrier, it's just the atmosphere, it's just air up there. But what happens is when the stratosphere starts, the temperature begins to increase as you go up rather than decreasing as you go up, which happens below it. And when that happens, air just does not rise easily because of something that we call atmospheric stability. So when cumulus clouds can grow, sometimes they get taller and then they reach a limit and they flatten out, creating this anvil shape. So let me go through these clouds. I'll show you some pictures, talk about them a little bit more. So here's yet another picture of your standard old cumulus cloud. Now, these cumulus clouds, you saw them before, they're the low cloud cumulus type. They're simply called cumulus. Sometimes they're called fair weather cumulus because they often accompany nice weather in the warm season in lots of places, including here in Wisconsin. Now, these clouds, you'll recall, are formed by convection, rising bubbles of warm air underneath it. Well, sometimes the rising bubbles of warm air are rising particularly vigorously. And also, sometimes the atmosphere is conducive to encouraging and accelerating that rise. When that happens, the clouds grow. So here's an example of the clouds growing. So you can see that this isn't the best picture in the world, but you can see that the base of the clouds are more or less at the same altitude, but the individual clouds are growing upward. So that's called cumulus congestus, or as my wife says, congested cumulus. So these are indicative of vigorous convection. And when you see this kind of thing, it means that you might get thunderstorms. These clouds might continue to grow up to the final level, which is a thunderstorm. And also, I might point out that here in the Midwest, these clouds are very common in the warm season. However, we have more humidity than they have in the West, like Wyoming, where this picture is taken. So visibilities aren't as great here as they are out in the West. So sometimes this stuff is happening, but you just can't see it because in the summer when it's warm, the skies are often hazy. All right, so here you have a particularly energetic looking cumulus congestus cloud. So this is that second stage. So this cloud started out as a baby fair weather cumulus cloud, and it's growing violently. I mean, you see the cauliflower look to the cloud. When pilots see these, they avoid them because the vertical winds, we're talking upward moving air, is sometimes 50, 60, 70 miles an hour inside those clouds to make it grow like that. So if you're a pilot, you don't want any part of that. So I have a little video taken on a beach in New York by a former student. So I don't know what the time range of this video is, maybe 20 minutes or something, but you can see this cumulus congestus growing. And that's what happens. That happens here in Milwaukee all the time, but most of us are much too busy to sit in one place and watch these clouds grow like this. But it's a cool little video. Okay. Now, when the growing cloud reaches the stratosphere, it can't grow anymore. Now it can, but it has to be really super strong in order to punch through the stratosphere. That happens, but only in the strongest, most severe of thunderstorms. So what happens for, 99.9 something percent of thunderstorms is they reach the stratosphere and they can't grow anymore. So what happens? Well, the tops of the clouds are at high altitudes where the wind are strong. So the tops spread out and they create this anvil shape, anvils like the coyote dropped on the roadrunner. So that's a characteristic shape. Now that is called cumulonimbus. So nimbus means precipitation. Cumulonimbus is also another term for a thunderstorm. So what happens is this vigorously upward moving air sort of reaches kind of a barrier. It's not, like I said before, it's not a physical barrier, but it reaches an altitude where that upward moving air can't continue upward. So it goes back downward. So now when you see a thunderstorm like this, you can infer that there is a vertical cell of air. You have air moving up, and in another part of the storm, you have air moving down. And when that happens, that's how you get precipitation, because the tiny microscopic sized droplets of water that make up the cloud, they move around violently, they smash into other tiny drops, and guess what? When two drops smash into each other, two tiny drops become one drop that's not quite as tiny. And when that happens enough, it becomes heavy enough to drop to the ground as rain. Here's an example of a tropical thunderstorm. This is taken in Ciudad del Carmen, Mexico, which is down at the bottom of the Gulf of Mexico. Thunderstorms very common there. A few more. Meteorologists love thunderstorms. We chase them, especially the ones that have tornadoes in them. Okay, this is a cool picture. So Sam Kahl, who now works as a broadcast meteorologist in Milwaukee, used to work in Wausau. And she's one of our graduates here. She took bunch classes with me. Anyways, a few years back, she sent me this picture. So this picture, it's kind of rare. I've seen a few pictures like this before, but not very many. So what happened here is that there was a cumulonimbus cloud, a thunderstorm, which had lightning, and lightning struck somewhere in the woods there behind this golfing green there. And the electric current from the lightning traveled along the wet ground and burned the grass in this pattern that you see. And this is a great reason why lightning safety rules are the way they are. I mean, they've changed over the years. When I was a kid, you're supposed to, if you're caught outside in a lightning storm, I was taught that you're supposed to go lie down in a ditch. Well, now we don't teach people that because we know better. What you should do if you're stuck outside is find a low-lying place and crouch down. Make yourself as low as you can, but don't lie down. Because if you're going to get killed by lightning, the way you get killed is if the lightning current passes through your heart. And if you are lying down on the ground, as shown in this picture, that could happen. So you don't want to do that. If the electric current passes through the grass and you're standing on it, well, maybe it'll burn the bottoms of your shoes or even your feet, but it won't stop your heart. Here's an example of sky with number of cloud types present. You see the cumulus clouds, you see cirrus clouds. I guess there's only two cloud types present, cumulus and cirrus. Very common. Sometimes if you have, let's say, stratus clouds, that's the lowest version of stratus clouds. Sometimes there's other clouds at higher altitudes, but you can't see them because the stratus clouds are blocking your view. Okay, let's talk a little bit about fog. That's another category. So actually fog is nothing special. Fog is just a cloud that occurs at ground level. So it's a cloud just like other clouds, but because it occurs there, we call it fog. So there's two main types of fog, and the names are based on their method of formation. So this type of fog, which is very common, is called radiation fog. And it gets that name because what happens is at night, the earth radiates its heat away, sort of like how a radiator in a house that has radiator heat sends its heat out to the house. It radiates it. Now, the earth does that too, and it does that all day long, 24 hours a day. But during the day, when it radiates, it also has energy coming in from the sun. But at night, the sun is turned off. So the only show in town as far as heat transfer is the earth radiating its heat away. So the earth gets cold at night. And the cold air sinks. So when you have topography like here, the cold air drains towards the bottom, and that's where the clouds form, called fog. Sometimes it's called valley fog, okay, but it forms by radiation, the earth radiating its heat away. Here's another example of radiation fog. Now, the other type of fog is called advection fog. Now, this is the classic picture of the Golden Gate Bridge in San Francisco. You always see the bridge mired in fog. So advection means movement. Specifically, it means horizontal movement. So what's happening here is warm air that has a lot of moisture, a lot of humidity, is moving horizontally, wind, to an area where the ground is cold. And it's cooling that way, as opposed to rising air, expanding and cooling and forming cumulus clouds. In this case, the air is cooling by moving horizontally. That's called advection. So the warm, humid air comes in contact with cold ground, or sometimes cold water, and it forms a cloud, advection fog. This kind of fog is common along the shore of Lake Michigan, where we live too. Here's a little time-lapse video from a satellite showing advection fog under Lake Michigan, on Lake Michigan. I don't know if you can see my mouse wiggling around, but this stuff here is fog. So what's happening is the air that's blowing from west to east over the lake is warm and moist, but the water's cold. So this would be a warm season, because that's the case. Yeah, it's May. So the warm air is moving over the cold water that causes the water vapor to get cold and condense, and all this stuff is fog, advection fog. Okay. So let's see. I got a couple more minutes. I'll show you just a couple of unusual type clouds, and then I guess I'll stop. Maybe you have some questions or something. So this is a cloud that is associated with a dust storm. So it's called a haboob. And I've seen these a number of times when I go to Arizona to visit my father. You can see from the cumulus type cloud above it that there's convection going on. There's rising air, but we're in a desert area, and that creates a dust storm too. Dust storms have weird individual names in various different parts of the world, but in the desert southwest of the US, they're called haboobs. This is virga, similar to those fall streaks that I showed you early on in the talk. This is rain that is evaporating before it reaches the ground. Very common in the western United States. These clouds are wave clouds. They're formed by air moving in waves. We saw that before with the cloud streets, but these are not this is a different type of wave. It's clouds that are moving in waves that are caused by mountains. And these clouds get a specific name. They're called lenticular clouds. Think lens, like contact lens, lenticular clouds. We don't get them around here because we don't have mountains. But what's happening is there are waves, and if you look upwind or downwind horizontally, you can generally see more clouds and more clouds and more clouds. The clouds indicate the tops of the waves, and there's clear sky at the bottom of the waves. This one is interesting. So here you have a developing thunderstorm or a cumulus congestus cloud. Now your typical thunderstorm has enough liquid water to fill an Olympic-sized swimming pool. So that's a lot of water. And water forms a barrier to air movement. So what's happening here is you have this huge thing in the sky, this developing thunderstorm. And up near the top, you have wind blowing, let's say from left to right. I don't really know what the wind direction is. And the air, the wind that's moving, it can't go through the cloud because the cloud is like a physical barrier. So it goes up and over and creates a little wave, and it creates that particular type of cloud at the top, which is called pileus. Okay, final one, then I'll stop. These are called mammatus clouds. Think mammatus, like memory, like cow's udders. These are the only type of cloud that can form as air sinks. Because normally when air sinks, the air gets warmer, water evaporates. That's sort of the opposite of a cloud. But what's happening here is you're looking at the base of a thunderstorm. And as I told you before, in a thunderstorm, you have this vertical circulation cell. So the part of the circulation where air is moving down sometimes pulls air downward from the base of the cloud, creating these sort of downward hanging cloud elements. And those are called mammatus clouds. Mammatus clouds are often a precursor to severe weather, but not always. So, okay, I had strict instructions to end at 10 o'clock, and it's 10 o'clock. So I think I'll stop sharing my screen here and be a good boy and stop when I'm supposed to.